Hey guys, so today I'll be working on two questions. One is the variant of the first one, and this is one of the most frequently asked questions at Meta. I'm going to be like posting the question now, and then we'll go from like what questions can I ask for my interview, and then what would be some of the approaches that could be done. Also like do the dry run at the end and try to do it for both the variants and the original problem. The goal is to like do this in about 20 minutes. So let me just set a timer for 20 minutes. Okay, so the first question is, given the root of a binary tree, return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. The length of a path between two nodes is represented by the number of edges between them. Okay, so this is not a binary search tree, right? No, that would be the answer from the interviewer. If it was, then it would be a different approach. So BSG, no. Then values in the node. I don't think it matters, but for now we can do integers. Maybe depth, like the height of the tree or depth of the tree. So that would be, let's assume, somewhere from 0 to 1000. Maybe, or maybe like if the interviewer says like a lower range or 1 to 1000, then edge case in the first condition, this condition would become, what if it's an empty tree? So we can just address that. I think and diameter may or may not pass from the root, right? So let's do example one. Let's say we have a tree, then the children are 2 and 3, then this one has 4, this one has 5, and then let's just assume this one has 6. And maybe we can do one more. So here 7 and this one has 8. Maybe this one would be 9. Yeah, all right. So for this situation, 1, 2, 3, 4, 5, 6, and 7 should be the answer. So is equal to 7. Yeah, so this is the root. Then if we go left, then we can do like a DFS kind of solution. So if suppose we do one process one, so depth here is 1, then we go down depth here is 2, then we go down depth here is 3. Then we go back up again till root and then go down and process the rest of the nodes. Like, and then we'll also have to do like the other nodes from here. So this would be like a O of n square solution because we are doing like a pre-order traversal and obviously not the most optimized solution. So one way to do this would be to just do a post-order traversal using prioritizing left. So in this situation, we can go all the way up till here and then we hit the base case where this is a leaf node. So it can return like diameter of 0 from, so this would return left as 0 and right as 0. And then when we pass this value to this one, we will add account for like +1 here to consider this edge. So when we are at 2, then here the left would be around, wow. So let's just do at this 2, left would be 1 from this edge. And then now we'll go down to right 3. And for this one, left would be at 0. And then right would be at 0 too for this tree, for this node. Then it comes back here, and then this would be max of these left and right, and then we'll add for that edge. Then we come here, and then now we have not done the right call, so this goes right down here. Then we'll check if this node has left and right. So again, this hits the leaf node. So this would return 0, 0 again because it does not have any children for this 7. And then when it passes back up for this tree, left would be, left is 1, and then this would go down right. So at this node, there is a left child, so this would be 0, comma 0. This would give max of 1, 0, comma 0, and then 1. So this would be 1 from the left subtree and 0 from the right subtree. Now what this will pass off here is for the right value. So this is 1, right? So this would pass on 2 because that would be the max there. So we called this 1, 2, 3, 4, 5, and we are done with this. Then this here would pass max of 2 plus 1, 3. So right would be 3 there because 1, 2, 3. So it will have passed 1. Then when it passed up, right. So that would be 2. Yeah, 1, 2, 3. And then when we are at the root, we will pass in 3 because that would be the max. And then we'll pass in 4, comma. Now we'll go down the right subtree. So we are here. We'll check for left children, no left child, and no only has right child. So this at this 3, we will have 0, comma 1. Yeah, actually, I mean, it'll go down right. It will check. We will give 0, comma 0. This will give 0 plus 1. So this would be 1. And then when it passes up again, it will be 2. Actually, the answer was 6. And yeah, that would be like plus 4 plus 2, 6 at the root node. And then we'll give the answer. So this would be time-wise O of n and space-wise O of h of recursion stacks. That's the height of the subtree. To I don't not implementing. I mean, let's just go ahead and implement class tree node, and we'll do define init stuff value left and right, none, none. I think we do have to initialize like left. Yeah, no. Value 0, left, right, none. Left dot, okay. Self dot val, equals val. Self dot right equals right. And self dot left equals left. Right now it's none, none. And then when we pass class, I mean, just do class solution. Solution. And then we can just define um, diameter binary tree, and it will pass some self and root, and the output would be an integer because we are getting the count. And we can have like a inner outer function here, which will be DFS, which will take in node, And the base case is if not node, we just return 0. Now we go traverse the left subtree, so just call DFS on none. And then we go traverse right subtree, which is DFS on node dot right. Actually, this would be node dot left. And we will return max of left and right plus 1. We will also have to keep track of diameter, right? So let's just do like a is equal to 0. So here's that diameter equals max of current self dot diameter and whatever the left and plus right value is. And we will pass in self here. Alright, I don't know if this needs self, but yeah, self dot DFS. And then here we'll just call in the function DFS and pass in the root node, and we just return this function. So this should take care of all the requirements here. And then the time complexity remains the same because we visit every node at most once. And for the space complexity, it will, if we do not found the recursion stack, then it would be O of 1. Yeah. And then a variant to this would be this question. So let's just so given a root of n array tree, you need to compute the length of the diameter of the tree. The diameter of an N-ary is the length of the longest path between any two nodes in the tree. This path may or may not pass through the root. Okay, so let's say here the example is 1, 2, 3, 4, and 5, and 6. And let's just add the last node here, 7. So now we need to traverse down this tree, and it does not need to have like multiple children. It only does not need to have only like two children. It can have multiple. For example, in this it has 3 children. So we have to do the same thing and traverse down and see. So here the longest subtree will be 1. So 1, 2, 3, and 4. So the answer here would be 4. It's pretty much like the same that we did, but what we have to keep track of maybe like max of two subtrees of two subtrees, which like which one to return back to the root, right? So here we'll have to check this subtree. So this would return true, then this would return 3, and then this would return this one. And also it would be 1, 2, 3, 4, 5. So 5 would be the answer here. And we can have like a max depth, max D1 and max D2. And what we can do is we can do the same for every children, keep going down, like for all its children, and then calculate the depth. And then if one depth is bigger, then we can override it. So for example, in this one, we start from the root, go for first children. So second, so right now let's initialize max depth as 0 and 0 for both. And then we go down 1. And then here we are at this child. Then we check 5 would give 0, 0, and then when we give it back up, then here this diameter would become 1. And let's assume that we already have like for this subtree. Yeah, so if we already have it for this subtree, let's say, then we can just return it back with This is the root node. Here we'll return max D1 and max D2 and basically add that here. So here the max D1 would be from this subtree and max D2, sorry, first depth would be this one, the longest one, and then this one. This tree would not add much. So like just to code it up, this would be again the same like tree node is defined. So I'm not going to do it again. This would be just N-ary, some N-ary diameter of an array, and it will take in root node. Actually, I mean, what do we pass in? Yeah, this would pass in root node, and again we'll return like an integer function. Base case would be actually we can just take the helper function DFS, which will take in node. And here, as discussed, we'll have maybe D1, D2, which would be initially at 0, 0. And then the base case is if not node, we just return 0. Now, for every child we have to do. So for node child in node dot children, this tree would have access to the children node. And then we call depth on this one. So node, so we call DFS on node child. And here we'll check if depth is greater than D1, which is max D1, max D2. So if depth is greater than max D1, then max D1 will be equal to D1 to current depth. And we don't want to overwrite like whatever was in max D2 because that would become the second largest depth. So for max D2, we can just assign it to depth max D1. And then else if depth or like now depth could be greater than D2, right? So this would just be that max D2 equals depth. And yeah, and then we'll just do max of self dot diameter and mm, max D1 plus max D2, D2. Yeah, and let's just self dot diameter. Actually, this one. And then at the end, we will return self dot diameter. And we also have to call like DFS on root. And for this part, what we should return is max of max D1, max D2 plus 1. D1, it's max D1. And this would be max D. Again, if we are using that. But if not, we could just, here, this is the issue. Okay, let's do this example quickly. Right now, the diameter is 0. Yeah, and we let's do 1, 2, 3, 4, 5, and 6. So we will go, we're calling the DFS function on root, right? So this condition does not execute. Max depth is still 0. D1, I mean, I'll just put it as 0, and D2 is also as 0. Then for node and node short children, so this would go in and D1. So now we are calling BFS on 2. That is the first for loop. Then we are calling here actually. So let's do node 2 first. Then we are calling DFS on 2. And then, well, time is up. I don't have enough time to do the dry run. I think there is some debugging here, but I will try to just go through it by my own. Thanks for watching.